John, maybe, is this an exciting time in AI? How are you doing?
Yeah, it's super exciting. I feel like I felt when I was, 25 or something. And I haven't felt that excited since then. And it's mostly not because of the industry. I mean, the industry is really exciting, but mostly because of the research. Like the prospect of, you think that there's been a revolution in AI over the last few years. There's going to be another one in the next 3 to 5 years. And that's what I've been working on. So it's kind of the next step. And I'm super excited about what might occur in the next few years.
All right, so I've broken this conversation into 6 parts. So the first part, I want to, let's building off of that, inspiration and career. What sparked your interest in artificial intelligence, augmented intelligence? I had someone else said ambient intelligence. I'm a neighbor of where Minsky lived. He's passed away, and I went up to his house. I said, why do you call it AI? Because in 1955, he and McCarthy wrote a paper to the government saying, hey, give us money so we can take these cybernetics studying people up to Dartmouth and kind of think about it. And he said to me, John, I could have called it BI, but I thought AI would sound scary and the government would give us money. How did you get into AI? Yeah, I just deleted the rest of my question. Hold on.
Well, I give a very long answer, so you have time to search.
No, here it is. What sparked your interest in artificial intelligence, and how has your career evolved over the years? And maybe this is to inform some of the young people here to think about their careers. And also, maybe you could contrast to how you think careers are going to be different, that maybe the way you did it is going to be different given the dimension of AI. But yeah.
Well, so it started a very long time ago, and Marvin Minsky had something to do with it. I mean, I was always interested in science, and sort of one of the things that I always found fascinating since I was a kid was the emergence of intelligence in animals and humans. And then when I was 9 years old, my parents took me to watch 2001: A Space Odyssey, and there was an intelligent computer. Like I didn't, even know the concept was even possible. Turns out the scientific advisor for that movie was Marvin Minsky.
Yeah.
Okay, in the mid-60s. And so when I was an undergraduate, I also learned about the fact that people had worked on machines that could learn. I thought learning was really an essential part of intelligence, maybe because I thought I wasn't smart enough to design intelligent machines from scratch. So, AI has to emerge by itself, basically, intelligence, natural intelligence as well. And I stumbled on another article by another MIT professor, Seymour Papert.
Yes, Turtle, logo.
Right, but before that, he worked with Jean Piaget, the Swiss experimental psychologist, developmental psychologist. And he wrote an article in a book which was a debate between Piaget and Chomsky about whether language is innate or learned. And here he was talking about the perceptron, a model that was originally developed in the 50s. And so I found the idea of learning machines absolutely fascinating. I started digging the literature. I was maybe in 2nd or 3rd year of electrical engineering studies, and got really sort of passionate about it and did sort of independent research projects with various professors on this, and then went on to grad school. And when I was searching for that literature, I discovered that Minsky and Papert wrote a book that basically killed the entire field in the late 60s.
The AI winter.
Well, the machine learning winter, because it was, there was a simultaneous winter in the 70s for both classical logic-based AI and machine learning-based AI, and that kind of was revived in the 1980s.
So if you had a DeLorean and could go back in time and whisper in their ear as the winter was unfolding, what would you say to them that you think might be profound or timely or interesting?
Well, that their interest when they were young, which was self-organizing learning machines, was the right path, and they abandoned it, and they basically convinced everyone else to abandon it. And that was a bit of a mistake. I actually discussed this with Marvin Minsky once, but I was a very young student at the time, and he said, no, it was good to kill it because it got us to kind of invent other things that would otherwise not have emerged, and he kind of had a point.
Yeah. So in terms of your earlier work, convolutional neural nets, how did that influence your later research direction?
Okay, so a lot of people think I worked on convolutional neural nets. So this was in the late 80s at Bell Labs. I actually started when I was a postdoc at University of Toronto.
Claude Shannon.
Yeah, he wasn't there anymore, but they were...
Rode a unicycle around MIT when he was at MIT.
Right, he was already at MIT by then, or retired actually. And people thought maybe I was interested in character recognition or something. Not at all. I was interested in building intelligent machines, and I worked my way kind of back. So you want to build intelligent machines, you're not smart enough to conceive it from scratch, so the machine has to basically build itself through learning. Now, how do you get a machine to learn? Okay, people had worked on this in the 60s, but the techniques were very limited, and it was pretty obvious back then that what was limiting was the fact you couldn't train a system with sort of more than one layer, basically. And so I started looking into like how can you train a system with multiple layers, what we call deep learning now, and discovered a rule that now we would call target prop, but was very similar to backpropagation. And that's what kind of got me into this. And then once you have a learning algorithm that works, the next question is, well, how are you going to connect those neurons so that they do something useful? And the only data that at the time in the 80s that we had access to were either characters scanned. You couldn't connect a USB camera on a computer back then, right? It was actually a major undertaking to get images into computers, and they were mostly like black and white. So the only two sets of data that were available at the time in sort of decent size were either character recognition or speech recognition. And speech recognition already had a lot of people working on it. Character recognition for printed was working fine, just handwriting wasn't. So I worked on this just because that's where the data was. And there were some potential applications which actually we ended up deploying in the mid-90s for reading checks and various other documents. So this was kind of a great thing where, and I think that's maybe a lesson in there, you set yourself a very ambitious goal, very long term, and you work your way back, and then you take the first step. And it turns out the first step usually is useful, and you have consequences that are relatively short term on this path towards AI. And since then, I've kept trying to make progress along that route, and convinced people like Mark Zuckerberg and Mark Scheffer, the CTO at the time at Meta, that this is the way you should organize research in industry. Have a very ambitious goal and then work your way back, and good things are going to come out of it, inevitably.
All right, so let me telegraph where I'm going. I want to ask you some questions about AI research in progress. Then I want to ask you some questions about challenges and opportunities. Then I want to ask you about meta and fair. And then I want to ask you about ethics and responsibility. And then finally, advice and legacy. And you're my favorite Turing Prize winner. All right, we have 18 minutes. So I'm going to just throw 3 quick questions, and you could pass or just say something pithy. What role did your experience with Yosha Benja and Jeffrey Hinton play in shaping your research interests? And with the new wave of Gen AI, what has changed in your view about AI? So quickly answer those, and then we got to get to the next thing.
Okay, Jeff Hinton has been a mentor. I admire him in many ways. When I was starting my PhD, he was the person I most wanted to meet in the world, because I knew he had understood this question of multi-layer training and hidden units, etc. We met in 1985, and again in 1986, and he offered me to do a postdoc with him, which I was super happy to do. So I did a postdoc with him 1987, 88. While I was in Toronto working with him, I gave a talk in Montreal, and there was this young master's student who asked really intelligent questions. That was Yosha Benja. And so after that, when I was at Bell Labs, I hired Yosha as a postdoc first and scientist afterwards. And so we've been working together on and off for the last almost 40 years now. We have a lot of mutual admiration. There are a few topics on which we really disagree. And one of them is existential risk of AI. So I think Jeff is completely wrong about this. I think Yosha is very largely wrong about that. And we disagree, we're still friends.
Great. New wave of Gen AI, just one sentence answer. What has changed in your view about AI?
So Gen AI has a shelf life of about 3 years now. Okay, everybody is excited about Gen AI.
Who's excited about Gen AI? All right, 3 years, he says.
Okay, what is Gen AI? Right? You train a system to predict what's going to happen next in a sequence. That's basically what it is. So it works really great for text. It works for DNA sequences. It works for things that are sequences of discrete symbols. If what you want to produce is not discrete. It's in a continuous world. So this idea, this paradigm of learning, by the way, is called self-supervised learning. Right? You don't have an input and an output. Everything is an input and an output, and you train the system to predict part of the input from another part of the input. Okay? Now, the idea that you should use this to train a system to understand the world by training it to, for example, predict video is very old. People have been working on this for a long time, including me, for the better part of the last 20 years.
Cat videos.
I mean, not just cat videos. You need diversity in the training.
No, I know.
But it doesn't work. It works really well for text. It doesn't work for video. And the reason is, you can't predict the next word in a text, but you can predict the distribution of all possible words. We don't know how to represent this for video. We don't know how to encode useful distribution of videos.
Let me go on to my next group.
So the punchline.
Okay,
Punchline is the only way to do this is to get rid of generative models altogether and train systems that learn an abstract representation of video and make prediction in its abstract representation. I call this JEPA. That means Joint Embedding Predictive Architecture. And that basically will swipe away generative models.
Okay, I'm going to ask a few questions. You decide what you want to answer if you think it's relevant. All right, what do you consider the most significant breakthrough in AI research over the past decade? That's one. What are the key challenges in scaling deep learning models to larger data sets and more complex tasks? That's two. How do you see graph neural nets evolving to handle complex structured data? And then I have one more question, but I'll wait till you take those three.
Yeah, I can't already remember all the three questions. So, okay, so first one is
the most significant breakthrough in AI in the last decade.
I mean, certainly architectural concepts that allow us to build deep learning systems by assembling modules that have different properties, I think is a great thing. So transformers certainly have been a super useful and fruitful architectural concept for this. They are equivariant to permutation, which is great. Convolutional layers are equivariant to translation. We're probably going to come up with new ones like that. Self-supervised learning, I think, is probably the most revolutionary concept that has really completely changed the way we practice machine learning over the last 10 years or so. And then there is other things like, systems that are augmented with associative memories and stuff like that. But there's going to be more progress along that line. Second question.
You know what, I'm going to go to a final question of this segment. Do you think AGI is real or is it a hoax? Is it as close as everyone says? What's your stance on AGI? Go.
Okay, so AGI is a misnomer. It really stands for human-level AI, and human intelligence is very specialized, so calling this general intelligence is complete nonsense. At Meta, we call this advanced machine intelligence, AMI, and we pronounce it AMI, which means friend in French. So I don't like the phrase AGI, but there is no question that at some point in the future, we will have systems that are as intelligent as humans in pretty much all the domains where humans are intelligent. The idea that somehow intelligence is kind of a linear scale is nonsense, again. Your cat is smarter than you on certain things, and you're smarter than it on certain things. $30 gadget or euro gadget that you can buy that beats you at chess is smarter than you at chess. So, I mean, the idea that somehow it's a linear scale and that, at some point it's going to be an event when we reach AGI is complete nonsense. It's going to be progressive. It's going to be, finding new concepts that will allow AI systems of the future to understand the physical world, which LLMs can do, have persistent memory, which LLMs don't have, are capable of reasoning and planning, which LLMs definitely can't do, right? So those are the 4 challenges of the next few years in AI. This is what I'm working on. This is what a good half of FAIR at Meta is working on. This is the next generation AI system.
So in terms of opportunities with AI, you just said what you think of AGI. How can we ensure that AI benefits everyone regardless of background, social, economic status? I know it's kind of like the Wild West. Let's create these tools. I think Web 2, there were a lot of winner-take-all. Privacy went out the window. Meta and Facebook and Google did really well. I think in this era of AI, there's some real opportunity to bake in some things. Uber didn't come about until 16 years into Web 2 when people said, oh, you can combine these things. I think there's going to be a lot of things we can combine with this technology that's happening now. What do you think of the opportunities to be an equalizer?
2 words, open source. So
How
there
did
is.
you get into open source? Did they recruit you and say, do this? Did you show up at Meta and said, we're doing this?
Okay, it's almost like that. When I was recruited by Mark and Mark Schaeffer, who was the CTO at the time, to create a research activity in AI, the first research lab at Meta, at Facebook at the time, I told them I have 3 conditions. First one is I don't move from New York, and I don't move to California. I keep my job at NYU because I need a foot in academia. And third thing is we have to practice open research and open source everything we do. And the answer to the third question, the answer to the first 2 questions was yes, and the answer to the third question was you don't need to worry about this. It's in the DNA of the company. We already open source all of our platform software, like React and things like this, and Open Compute and all that stuff. So like, you don't need to worry about this. I say, okay, where do I sign? It's the first time I heard this from any company that I either interviewed with or worked for before. And so I thought that was like the most interesting aspect of it. And so we've been practicing open research. We had the effect of actually causing other labs like Google to actually open up a little bit. Google Brain, was publishing, but not nearly as much. And they opened up. And this is one of the big factors that caused the rapid expansion of AI over the last dozen years. The fact that scientific information, code, and everything is freely exchanged, it accelerates everything. Okay, so that became kind of a major evidence for the management at Meta that this was really good, not just for the world, but like for the entire industry and for ourselves. We get a lot of feedback and a flywheel of innovation from people using our tools. So that's why we not only open source PyTorch, but we also transfer the ownership to the Linux Foundation. PyTorch now basically is the basis for all, pretty much all AI R&D today, including OpenAI, by the way. ChatGPT is built on PyTorch. But I think there is a more important reason for it. 2 more important reasons for it. So the first one is the AI industry is largely built on top of open source foundation models today. And a lot of the startups that you see are built on top of Llama or Mistral or some other open source engine. So there would not be an AI industry that we know today if it were not for those open source platforms. That's the first thing. Second thing is, in the future, every single one of our interactions with the digital world will be mediated by AI assistants. From a smartphone, for smart devices like those glasses, I can take a picture of you guys. Smile. And what that means is that all of our information diet will come from AI assistants. We cannot afford to have those assistants come from a handful of companies on the west coast of the US or China. It has to be highly diverse. And the only way for it to be diverse, which relates to the previous question, is open source foundation models that are then fine-tuned for vertical applications or for learning every language in the world, every culture, every value system. And that's how you get a diverse population of AI assistants. We need that for the same reason we need a diverse press. Okay, so it's very important for democracy to preserve open source and to not legislate it out of existence.
Well put. 5 years ago, did you think what is happening now was going to be happening now? I talked to Sebastian, who's at Microsoft Research, and he said 5 years ago he thought everything happening now was going to happen 90 years from now. He was very emotional because he said, things his kid is going to be using, he thought it was the next generation. Is things on track to how you thought they'd be, a little ahead, or what's different?
Well, 5 years ago, it was pretty clear that things like dialogue systems and self-supervised learning in the context of language was going to have a huge impact. It wasn't clear for the wider population because ChatGPT hadn't been in front of everyone, but there were systems that were being worked on at Meta, at Google, at OpenAI, various other outfits that made it pretty clear where this was going. So yeah, it was pretty clear 5 years ago. Now Sebastian is an interesting guy. So he came from like a very theoretical mathematical background. He was head of the theory group at Microsoft Research. And he had an epiphany. He kind of resisted deep learning. He didn't think that was interesting because, theoretically it's just too complicated. And then he had an epiphany one day with, playing with with GPT-4 and say, oh, wow, this is really, really cool. And, wrote this paper about, the sparks of AGI, and he quit Microsoft and now he's working at OpenAI. So
he was with me the day that he published that paper and it went online, and he was very emotional.
Right. And I think both of his opinions, before and after the epiphany, actually were excessive.
Yeah. All right. I have one. My last question is going to be for you to say something that people don't know that you think is important, or something like that's unique to your perspective. I mean, I'm kind of curious what you think your legacy is right now in the AI world, and what do you think it will be? That's my last question. But the question before that is, I think AI can be scary. What are some potential risks or downsides of advanced AI systems, and how can we mitigate them? I'm a techno-optimist, but I think we need to be aware of the challenges. So before I ask you about your legacy and you give these guys and ladies the inside scoop,
Okay.
What about that?
So let me talk about risk and benefit. I mean, the benefits far outweigh the risks. Benefits in like every corner, not just like economic growth and things like that, and progress in science and medicine and safety and all that stuff. But also the fact that everyone will basically be smarter because of AI, right? If we walk around with those AI assistants that are with us at all time, they will amplify our intelligence. They will work for us. They're not going to dominate us or anything, right? They're not going to kill us all or anything. They're going to do what we tell them to do, but they might solve problems in a smarter way than any individual of, any people in this room, including me, can do. Now, we're very familiar with this concept. At least I'm very familiar with the concept of working with other people who are smarter than me. And this is the way it's going to happen. You're going to have a staff of people working for you, virtual people, that are smarter than you, and they'll just make you more productive, more creative, smarter. And amplifying human intelligence, I think, is the best thing that we can do ever. The last time this happened in a big scale was following the invention of the printing press, which allowed the dissemination of knowledge and philosophy, and basically brought down the feudal system in Europe and brought the Enlightenment, and then caused the American Revolution, the French Revolution, and emergence of democracy. I mean, this had like enormous impact, right? Just the dissemination of knowledge. So AI may have kind of the same effect, but the next step. It's going to be a new renaissance, perhaps, for humanity. How about that for a legacy?
I think well put. So you got a few minutes. Just say what's on your mind. Like right now, I think Demis is in another. Demis is somewhere else. He has a lunch. I think we have a bigger group than that one. You got a captive audience. You got world leaders. You got corporates. You got techies. You got the MIT community. What do we need to know that you know? Here, use this. This is your stage.
Okay, AI is not going to kill us all, first of all right? Future AI systems will be on a very different blueprint from current ones. And to some extent, they'll be safer in the sense that they'll be more controllable. So what I've been a proponent of is something called objective-driven AI. So basically an AI system that sort of elaborates its answer by optimizing an objective subject to guardrails. So that makes those systems controllable, which is not the case for LLMs. LLMs don't optimize any objective. They just kind of produce one token after the other. So future systems will be smarter, capable of reasoning, hopefully capable of understanding the physical world, have common sense, but they'll be controllable because of those guardrails and objectives. And it's not super difficult or unusual to design those guardrails. We're familiar with doing this with humans and superhumans, entities called corporations, and that's called making laws, okay? So we know how that works. So they're not going to kill us all. Future systems are going to be very different from current ones. There's going to be a revolution coming, another revolution in AI within the next 3 to 5 years due to those change of paradigms. And this may open the door to systems that not just can pass the bar exam and solve math problems, but also like do what a cat can do. Like we have no idea how a cat becomes so smart so quickly and can understand the world so well, much better than any robot we can build. And so if we can crack that nut and understanding the physical world, have common sense, we'll have systems that can power domestic robots, level 5 self-driving cars, which still don't exist, and all the stuff that we've imagined. And so maybe the next decade will be the decade of robotics if we can make that step towards the next generation AI systems.